The diagram above shows a sketch of the curve with the equation y equals f of x. The curve passes through the point 0, 7 and has a minimum at 7, 0. On separate diagrams, sketch the curve with the equation a, y equals f of x plus 3. So the plus 3 is on the outside of the function, so it affects the y coordinates only. And we do what the equation tells us to do. We're going to add 3 to the y coordinates, the x coordinates staying exactly as they are. So the coordinate 0, 7 is going to move up to be at 0, 10 now up there. The coordinate that was at 7, 0 is going to move up to be 7, 3. And every point is going to move up 3 units in the y direction. So our graph's going to look something like this. So it's going to cut through the y-axis at 10 there. It's going to have a minimum at the coordinates 7, 3. Looking something like this. So that's my answer to part A. Part B, we want to draw the graph of y equals f of 2x. The 2 is on the inside there. So that 2 affects the x coordinates, and we do the opposite to the x coordinates. So instead of multiplying them by 2, like you might expect with 2 times x, we're going to divide the x coordinates by 2. So the point here, the y-intercept, well, that already has an x-coordinate of 0. So dividing that by 2 will still be 0. So that point doesn't move at all. That stays at 0, 7. The minimum point, however, the x-coordinate there is 7. We're going to divide that by 2, which will be 7 over 2, or 3.5. So this point squashes in by a scale factor of a half there. And in fact, every point is going to get divided by 2 in the x direction, so this whole graph is going to squash in, and it's going to look something like this.